In this video, I want to talk to you about square root functions, or what are sometimes referred to as radical functions. The key for a radical function is that you'll see this square root symbol. Now there's also things like cube roots and fourth roots and fifth roots, but for this lesson we're just going to focus on square roots. And so you've got a square root symbol, and then underneath it is x. Let's take some values that we might plug in. -1, -2, -1, -2, 0, 1, 2, 3, 4, so on and so forth. If I plug a -2 in here for x, the square root of -2 does not exist. There is no number that you can multiply by itself and get a negative number. So that would also be true for the square root of -1. The square root of 0 is 0, because 0 times 0 makes 0. The square root of 1 is 1, because 1 times 1 makes 1. The square root of 2 is approximately 1.4-ish. And that's because the square root of 2 is what we call an irrational number. And there's not a clean number times itself that makes 2. The square root of 3 is very similar. You get approximately 1.7-ish. The square root of 4 is a nicer number. It's 2, because 2 times 2 makes 4. And you can see if I plug in a 5 or a 6 or a 7 or an 8, we also get some of these what we call irrational numbers, which then we approximate with their decimals. The next clean one we would get is 9. The square root of 9 is 3, because 3 times 3 makes 9. So if I take these points over here that we've created, -2 is not on there, -1 is not on there, but 0, 0, 1, 1, 2, 1.4, so on and so forth, and throw them on the graph, let's see what this would look like. We have 0, 0. We have 1, 1. We have 2, 1.4-ish. We have 3, 1.7-ish. We have 4, 2. And then we said that the next clean one would be 9, 3. Now I want to be clear, the numbers 5, 6, 7, 8 can be plugged into this function, and you can get out decimals to approximate them. Let's see what this would look like when we graph it. So this is the general shape of all radicals. It has a hard point here, not an arrow. It looks kind of like half a parabola on its side. If you think about what parabolas look like, it looks kind of like half of a parabola tipped on its side. The values for y will continue to rise forever as we move forever to the right. There is no picture over here on this part of the graph.